Today we are going to learn about inscribed angle. With circles, geometry becomes at once more interesting and more difficult. Combining curves and straight lines, circles create whole new possibilities. A common figure involving a circle is an inscribed angle. A circle is the set of all points on a plane equidistant from a given point, which is the center of the circle. The only way to gather all the points that are the same distance from a point is to create a curved line. Here are some of the main parts of a circle. A circle has other parts too, not important to this discussion. Secant and point of tangency are two such parts. Circles are almost always indicated by the mathematical symbol followed by the circle's letter designation, its center point. This, for example, is A with chord BC and arc DE. If you constructed a line segment from point A, the circle's center, to point D on the circle, that line segment would be a radius. Running a chord from point B to point E would give you a diameter, which must run through the center of the circle. The definition of an inscribed angle is an angle whose vertex lies on a circle and its two sides are chords of the same circle. In this example, we have constructed an inscribed angle. We selected 3 points on the circle, points G, H, and I. We connected G to H with a chord, GH, and we connected H to I with a chord, HI. This means angle H is the inscribed angle. The inscribed angle theorem tells us that an inscribed angle is always 1/2 the measure of either the central angle or the intercepted arc sharing the endpoints of the inscribed angle's sides. Let's look at our formula. The inscribed angle equals 1/2 times the intercepted arc. For example, let's take our intercepted arc measure of 80 degrees. If the inscribed angle is half of its intercepted arc, half of 80 degrees equals 40. So, the inscribed angle equals 40 degrees. Another way to state the same thing is that any central angle or intercepted arc is twice the measure of a corresponding inscribed angle. This formula looks like this. If we plug in our numbers, we get 80 degrees equals 2 times the measure of the inscribed angle. When we solve the equation, we get 40 degrees for the inscribed angle. Both formulas give us the same answer, 40 degrees. Circles have some surprising relationships between their parts. For any inscribed angle, the measure of the inscribed angle is 1/2 the measure of the intercepted arc. That, of course, is the inscribed angle theorem. An inscribed angle has very few rules. Its vertex and endpoints of its sides must lie on the circle. And that's about it. That means an intercepted arc can have dozens, even hundreds, even thousands of inscribed angles. You can move the vertex of the inscribed angle around the circle, keeping the sides' endpoints pinned to the intercepted arc, like this. All these inscribed angles are for the same intercepted arc, and yet every one of those inscribed angles measures 30 degrees, in compliance with the inscribed angle theorem.